This unit, actually from here on out, has a completely different flavor than your experience with physics so far. It has more of a chemistry flavor. So, in the fact of like, up until now, you could visualize stuff by like, let's pretend I'm driving, or like, let's throw a ball and see what it looks like. You've interacted with the objects that we've discussed, how and why things move. In chemistry, you can visualize stuff, but you've never really truly taken an oxygen atom and stuck in hydrogen, and then took another hydrogen, stuck it on there, like, hey, look, water. Like, you've visualized it, you've done Lewis dot structure, but you've never actually like touched it. And does that make like, okay? So you have that same feeling for especially this unit, next couple units. It's just different. So we'll get to some of that. All right, so a little chemistry review. So what is found in the nucleus of an atom? Protons and neutrons. And where do we find electrons? Whirling around. Good with that? Okay. Okay. So, when you're doing studying, electrons were the focus. Like you're doing Lewis dot structures, the focus was electrons, right? Electrons will still be the focus, actually even more so than, we don't really care about neutrons at all in this class. Electrons are like where it's at. We do incorporate protons somewhat, but like electrons kind of the focus. Okay. So if you have an object that is positively charged, what does that mean in terms of electrons and protons? How does something become positively charged? More protons than electrons. And something that is negatively charged, more electrons than protons. And something that is neutral or has no charge has the same amount. Not no charges. They're still making it out. Like there's still protons and electrons in there. They're just equal amount to cancel each other out. Here's that. All right. So what happens when two objects that have the same charge are brought near each other? What do? They repel. And opposite charges attract. Here's that. Okay. Hey, we're doing pretty well right now so far, right? This isn't like groundbreaking. Okay. So conservation of charge. This is just a general law in science that says if you go through a physical change or a chemical change, a chemical reaction, we're not creating protons, we're not creating electrons. The charge, all the charge is still there. It's just rearranged in different ways. I mean, it's conserved. It's there. It just might be in different parts of the molecule or on a different molecule than in this one or something like that. Okay, so it's just a kind of a big idea of conservation of charge. All right, talked about that. Electrons are the only thing that move. The protons are stuck in the nucleus. Electrons are the thing that are whirling around. Okay. So give me some examples of electric conductors. What materials are conductors electrically? Iron is one. Yep. Copper. Yep. Yeah. probably. Okay. So we could list a bunch of them. In general, metal, gold, silver, those are popular conductors as well. Water, it's a ish. It's not a salt water, definitely more so. Uh, but yeah. Okay, so we're gonna just stick with metals there. Conductors, what do they do? Why do they conduct? Because these allow electrons to transfer easily. Allow electrons to transfer easily. Okay. And microscopically, why is that? So chemically, like on the periodic table, you have your two towers. You have your your hydrogen and your helium. Okay. And then in between the two towers, you had the valley that made up transition metals. Okay. I don't know if you've heard this catchphrase of transition metals, but they're characterized by having a sea of electrons is the phrase. I don't know if that's hit or miss regardless of who you had for chemistry. Sea of electrons. This means like um, you have a chunk of metal. There's no one atom that has a certain electron. It's just a collective quantity of electrons. Like, kind of reminds me of a hippie community. Where like, dude, my electron's your electron, man. That's cool. Like, man, can I have an electron? Yeah, man. Yeah, good. Hey, you want one of these? Sure, I'll take an electron. It's just one big commune where it's not one atom doesn't have an electron. It's just collectively. Does that make sense? Sea of electrons. Okay. It's still neutral. The overall charge of the object is neutral, but it's not like associated with one atom. Okay. So does that make sense why electrons are able to transfer easily with the sea of electrons? Good. Okay. Insulators. Give me some materials, examples of materials that are an electric insulator. Start shouting them out. Ooh, yeah, probably too abstract, but what? Rubber. That's one. Lots of them. Plastics, yeah. Ceramics, wood. Okay. Glass, yep. Okay. That was good enough. Okay. What does an insulator do? They resist electrons from transferring. They resist electrons from transferring. Microscopically, the molecules are possessive of their electrons. Okay, they're possessive of their electrons. In chemistry, you did Lewis dot structures with like covalent bonding, and you were always going for the happy 8, right? You're trying to hey man, I'm trying to fill out my valence shell. I need 8 electrons. Once you have 8, you're good to go, right? Okay, that would be kind of the mindset of an insulator. Like, hey, could I have an electron? No, get away. Like, hey, do you want one? No, I don't. Like, stay away. I got my 8. Okay, it kind of reminds me of America's suburbia. Like, everybody's in their houses, you got your picket fence. You kind of know your neighbor, but not really. Everybody has a lawnmower because you use it like, once a week maybe. But like, hey, can I borrow your lawn? Go get your own lawnmower. Like, this is mine. like you're like, sad commentary. All right, good with that. Okay, so all right, so crystal lattice is a term that we use for how the molecules in a material or of an object arrange themselves. Okay, how they stack together. So you'll see, like, if you type in crystal lattice on the internet and like type images, you get things like this. Here's how I'm going to draw my crystal lattice. This is how they're in an object, the molecules are going to arrange themselves. What this represents is the nucleus. It's positively charged, and these represent the electrons. This does not mean there's 1 proton and 4 electrons. This just means positive charge nucleus, negatives on the outside dancing around. Okay, but this would be an example of a neutrally charged object. Okay, so a big difference between chemistry and physics. Chemistry, you focused on a single atom or a single molecule. In physics, we are focusing on objects that you can hold in your hand, that you can see with your eye. You don't need a microscope. You can just hold it and feel it. And so it has like quadrillions of atoms or molecules that make up this macro-sized object. Okay, so that's a big paradigm shift of how to think. Okay, so when I give this diagram, this is not an electron. This is like a negatively charged bowling ball. Okay, you can hold it in your hand. Okay, and this we're going to say is a neutral slab of conductor. Let's say, just to give an object to it, let's say it's a 45-pound plate for weightlifting. It's just a slab of iron. Okay, it's neutrally charged. Okay, and what happens inside this plate of metal when you bring a negatively charged bowling ball near it? How does that respond to the presence of this negatively charged bowling? We're not touching it, we're just bringing it close. So here are your choices. Protons move towards, electrons run away. Protons stay put, electrons run away. Electrons run towards, protons run away. Electrons run towards, protons stay put. Thumbs up when you have a guess. Okay. One of the benefits of physics here on out is you don't have a whole lot of misunderstandings. Like all last semester, you had this idea of how and why things worked and moved. Sadly, most of those conclusions were wrong initially, and that's what made physics tough. Was I had to break those bad ideas and build in good ideas. This stuff, it's kind of like chemistry. Like, you didn't have many misconceptions of chemistry. You're just like, teacher says this is how it happens. You're like, okay. This has a similar flavor to that. Like, here's how it works. So in some cases, I'm going to put questions up here, but I'm not going to have you discuss because it's kind of like the blind leading the blind. You don't know, and the conversations aren't very productive or like effective or efficient. So I want you to guess, but then I'm going to tell you what the answer is. Okay, there we go. Guess. Correct answer. Hopefully we eliminated C and D because likes repel, opposites attract. Okay. The correct answer is B. Okay. Where are the protons found? In the nucleus. Okay. So the nucleuses themselves are not migrating. Okay. It's only the electrons are free to move. Okay. So protons stay put, electrons are free to move, and they run to the far side of the metal plate. Good with that? Hey, Mega. Why is it not? Is it just the electrons are attracted to the object? So this is a negatively charged object. So the electrons are going to be repelled by something else that's negative, not being attracted to a negative. Does that make sense? Like charges repel each other. Get with that? So it's like two magnets, South Pole, South Pole. It's like, ah! Okay. All right. So I'm going to throw out a chemistry term. I'm looking for my chosen polar molecule. Water would be an example of a polar molecule. Yeah. Okay. Let me just give you some quick. That is such a classic thing you should know. Okay, here we go. Ready? Those folks who had the special teacher. Ready? Okay, you have oxygen. Okay, and you have hydrogen, hydrogen. What molecule is that? Good job. Okay, good. All right, we're good. We're tracking. Okay, so that's a water molecule, H2O. Okay, this side, because it has the hydrogens associated closer to this side, it's partially positive. Okay, and this side has more of the electrons over here, and therefore is partially negative. Water would be an example of a polar molecule. That's how we describe that. Overall, it's neutral. All their valence shells are filled. They have the same number of protons and electrons. So overall, the molecule is neutral, but it has a positive side to it and a negative side to it. And that's the symbols we use for partially charged positive and partially charged negative. It's a polar molecule. So there you go. Okay. And this is why water does a great job dissolving stuff, because it's a polar and it's able to pull apart other molecules. Okay, we'll just leave it at that. So there's your chemistry crash course. Okay. So in this arrangement, this chunk of iron, this weightlifting plate, has electrons on this side. So this side is partially negative. And there's a lack of electrons over here. This is partially positive. Overall, it's still neutral because you haven't lost or gained any electrons or protons. They're all there. They're just segregated. Does that make sense? So we could say that the iron plate is polarized. It's a Greek character. That's a pretty good one. Delta. Is it delta? I think so. Lowercase delta. We'll go with it. So anytime you use like polar, it's because one side is partially negative, one side is partially positive? Yes. Yep. Polarly charged. You can get other. Yeah, that's what it is. Nice. Okay. Go to that. All right, so we just talked about that. So what would happen if we repeated this experiment, but this time with a neutral slab of plastic? So it's an insulator. We bring our negatively charged bowling ball. What's going to happen inside that slab of plastic? Here are your options. Nothing. Here, electrons run to the far side of the molecule, and that happens throughout the entire, all the molecules in the plastic. All the electrons run to the far side of the piece of plastic, or molecules run to the far side of the molecule, but that effect diminishes as you get farther and farther away from the bowling ball. Thumbs up when you have a guess. Correct answer is D, dangerous dinosaurs. Okay, so they are responding to the negatively charged object. The electrons are being repelled, but they're being repelled to the, in the suburbia analogy, to the back wall of the fence, like like no, like the molecules like stay in here, like no, I leave. Okay, but they're like bound to the molecule. Okay, but that response weakens as you go away from the negatively charged bowling ball. It's kind of like, oh man, that sucks. Their house burnt down. Glad it's not mine. And life goes on. Little encouragement for getting to know your neighbors. Go to that. All right. So, question for you. In chemistry class, the correct answer would be C. But in physics, because we're talking about a macro-sized object, not just a molecule, this side is partially negative, this side is partially positive, this side is attracting, this side is repelling, but this side wins because it's closer. There's a stronger force of attraction to the oppositely charged than there is repulsion. I got class right now. Oh, yes, I do. You're right. Thank you. Rose. I'll just do this. Thank you. Oh, no. All right. So, yeah, so it attracts because the force of attraction is greater than the force of repulsion simply because it's closer. Go to that. What? What? A. Yes. Yep, sure can. Sure can. So yes, it attracts. And the reason why is because this side that is partially positive is closer to the oppositely charged object. And so there's attraction here. There's repulsion here. Okay, but because this is closer, there's a stronger, the force of attraction is stronger than the force of repulsion. So overall, it attracts. You okay with that? It attracts so that your negatively charged bowling ball, there'll be a slight force of attraction from the neutral plate. Good with that? It's not enough to move the plate. It's too heavy, but there is attraction. Okay. So last slide. Thumbs up when you have a guess. Have a conversation.
And I know I won't be doing
Did you make like your account? Yeah. He's gonna be like taking him the second I got in.
It better not be.
No, I don't.
Yeah.
I think like
Correct answer is? Correct answer is finicky foxes. Good with that? Okay, that's the lesson today.